Hello guys, welcome to this lecture. This is a continuation of functions, and in the previous videos I could have explained you about what are functions, why functions are required, and about also the parameter passing. So there were three types of parameter passing: pass by value, pass by address, and pass by reference. Where pass by value was available in C, pass by address is also available in C, whereas pass by reference is not available in C. It is available only in C++. But to show you the difference between pass by address and pass by reference, I showed you that. Now again, coming to arrays as parameter. Arrays as parameter. Still now we have just passed one integral value. Only single data we were passing, and we were seeing about that. Now we are going to pass collection of elements, arrays. Okay, so we will check how the behavior how behavior is there for the function when we pass a array. Okay, we'll just go forward. What I will do is I will just declare a array of size 5, and I will initialize it to 2, 4, 6, 8, and 10, for example. And then what I will do is I will just write a function, a void function. It means that the function will not give back anything to the main function back. So let me keep the name of it as func, and followed by it has to accept a array. So first of all, the data type of the array has to be mentioned. Parameter means the information that is sent by the main has to be received here. Okay, so we are sending an array, so how it has to be received? Integer. Then the name should be given for an array. It can be either the same name, also it can be different name, that we have seen in the previous videos. So let me keep a different name, and if I just simply give int b, this refers to a scalar variable, but this is not a scalar variable, this is a vector variable. So in order to mention that this is going to be a vector variable, I have to mention a subscript in the right side. No size need to be given here, only the subscript we are going to. I'll just tell you why the size is not need not to be provided there. Okay, fine. So what we are going to do is that after accepting b, I will just simply, what I will do is I will just change certain elements. I'll just change certain elements by using the index. For example, b of 0, let me change it to 100, and b of 3, let me change it to 200. So two changes that I have done. So now what I will do is, after just I'll just call the function func, and I will just pass a. I'll just simply pass a, the name of the variable alone. No subscript, no size, nothing. I'm just passing the name of the array. Okay, then let me, after calling this function, let me just print. Okay, let me just print. For example, I will also declare a variable called I for the loop, and I'll just declare I is equal to 0, 0th index, starting from 0th index, and I have to print up to 4th index, which means less than 5, I plus plus, and I'll just print a of I, percentage d space a of I, so that all the elements of the array will be printed after calling the function. Why I'm printing after calling the function? Let us check whether the changes that we have done in the function is affecting the original array or not. Okay, so we know that very well. This the parameter that we are passing during the calling process is called as actual parameter, and the parameter which is received here in the declaration signature part is called as formal parameter. Okay, formal parameter. And I told you that there are two kinds in C. There are two kinds. One is pass by value, pass by address. If it is pass by value, I told you very clearly that any change in the formal parameter will not affect actual parameter in terms of pass by value. If it is pass by address, any change that you do with the formal parameter will affect the actual parameter in terms of pass by address. So now we will check whether this is passed by value or passed by address. Okay, we will just simply, first of all, we will do the compilation process, and then we will check whether what is happening here. I'll just go for the compilation process. Compilation successful, executed. Can you able to see here? I have declared 2 4 6 8 10, but here displayed is 100 4 6 210, because the changes that I have done in the function is reflecting here in the main function also. It means that whatever change that I have done to formal parameter has affected actual parameter. It means that this is not a pass by value, this is actually pass by address. You might ask me, we are just simply passing a, right? So this has to be passed by value. How it becomes passed by address? I'll just tell you, this is a big drawback of array, because C has been designed in the manner that array cannot be passed by value. Whenever you pass a refers to the address of the first element of the array. A refers to the address of the first, the name of the array is referred to the base address, the first element address of the array. So what you are passing here, you are not passing the value, you are passing the address of the very first element. So using that, what we can do, we can access all the elements one after the other, that I have taught you in the pointer section already. So you're passing the address, and now if I'm passing the address, what this can be, if I passing the address, then the variable has to be address variable to receive it. So this is not a array variable, this is a pointer variable, which is automatically converted, understood by the compiler, that I will show you here. I will just show you that this int b is taken as a pointer variable. I'll just show you. One minute. Yes. So execution started, a main activation area is created, and inside the main activation area, two blocks are there. One is I, and another block is array block A of size 5, and garbage values are there. So when ninth line is executed, automatically all these elements are assigned to 2 4 6 8 10. And now I'm calling a function func of a. Now we will see, whenever another function is called, what will happen, a new activation area will be created on top of the existing activation area. So I will just enter into activation. So if you see here, one more activation area is created on the top, and also you can see this int b bracket is automatically changed to int star b. It is taken like a pointer. And also if you see here in b is receiving the address of a. So a refers to the address of the very first element called 2. So you can able to see it here by expanding. Yes, it is referring to, it is the address. So b means address of the first element, star b means the value of the first element too. Okay, I have already told you the difference between b and star b. Okay, fine. So now, since this is a pass by address, you definitely know the changes that you do here will affect it. For example, I will just change the fourth line. So b of 0, can you able to see here that 0th index element is changed to 100. But again, I will go to main function and we will check a whether it is changed or not. I'll just go to main function. A 0th index is also changed, because it is passed by address, because this is passed by address. Okay, so what I will tell you is that whenever you are playing with the array, your array cannot be passed by value, it can be only passed by address. So whatever changes that you do with the formal parameter will definitely will affect your actual parameter. And you might ask me whether we can able to return any array. Yeah, you can able to return array, not array, a pointer, because you are able to pass array as a pointer only. So you are able to pass the array by address, and that address is received by a pointer. So you can return a pointer only. But one thing I will tell you, there is no need of returning it back, because already you know that the change that you do with formal parameters is already affecting the actual parameter. Then what is the need of again returning it back? But suppose if you want to return, what you can do, you can change this return type as integer a bracket. So this is automatically converted to integer pointer wherever this bracket, because this I'm telling that you are returning a pointer, returning a array element. Okay, so when int open bracket and close bracket is given, then when open bracket and close bracket is given, then I have to return Okay, this means that it is telling that we are going to return a pointer, because already you know that this bracket is automatically converted to pointer. Similarly, this bracket also will be converted to a pointer. So this is literally equal to int star. So I'm giving int open or close bracket. You can ask me whether you can give star. Yeah, you can also give star, you can also give bracket. Both will do the same work only. So what I can return now, I can return b, because what is b is a pointer variable. So simply if I say b refers to the address that I have shown you here itself, b address star b value. So I'm returning the address only. If I'm returning the address, I think this address can be received by, I think it is showing error here. Okay, it is showing a error. It is showing error. It means that this might be a problem. This open close bracket might be a problem that we will see. If this bracket is a problem, then we can go with the star. Okay, because but in most compilers, this open close bracket system will work. Okay, but if this is a problem here, we can change it into a star. That we will do later. But I'm returning a pointer here. If I'm returning the address, because b means simply it will refer to address, right? Fine. So I'm returning an address. If that address has to be received here, address can be received by a pointer variable only. So you need to declare one more pointer variable, for example integer x, sorry, star x, integer star x. So what I can do here is I can write x is equal to, because a pointer variable only can receive a address, since we are receiving address. So now if you see, x also refers to the same b. It means that a referred by b, now b is referred by x. So all the three are referring to the same way, same memory location only. All three are, all three variables are referring to the same memory location. So now if you have doubt, we can, what we can do is that we will print two integers. A of I also we will print, x of I also we will print. A of I also we will print, and x of I also we will be printing. Okay, so now we will just go for the compilation and check whether first of all any error is there or not. Okay, if error is there, we will just look into it. Yes, there is error. What is the error? Actually both are actually warning, but here, yeah, there is a problem with that. As I said, that there's a problem with that open close. So if this is a problem, then we will change it to star, integer pointer, and now we will check whether this is working. Yes, now compilation successful. See, that system also should work. It means that this is not, that is not a wrong method, but here in this compiler we are not, it is not working. Okay, so but here I told you that giving bracket and giving star is also the same. So now we are changed it to a pointer, and now we will just go with the compilation process. And if you see here, this is, see, we are printing a of I, x of I. So a of I 100, x of I 100, 4466 200. So both are referring to the same, both are having the same value. This is the reason why I'm telling is that no need of returning a array back from a function. Suppose you are passing array, suppose you are creating array here, then okay, then if you are creating an array here, then that array you can return. So how to return it? You have to return it as a address, and here you have to receive it by using a pointer variable. So two things, parameter passing and parameter, I mean, and also value returning back the value. Passing the value, passing a parameter is actually passed by address. So you are not passing a value, you are passing the address, and this address is received by a pointer variable, and you are processing it. Whatever change that you are doing here will affect your actual parameter. And finally, if you want to return back the array, you have to return back the address, and that address will be received back by a pointer. So you are sending a array, sending the address received by a pointer variable, and you are returning a address, and it is returned by, it is received by a pointer variable. So one thing is very clear, whenever address is coming into play, then you have to go with the address variable called pointer. Okay, so this is a complete system of pass by, how to pass a array to a function. This is an example of how to pass a array to a system, to a function. Okay, fine. Okay, right. So what is the next thing that we can do is that we can just go with structure as parameters. Okay, we will just go with structure as parameters. See, one more thing before going to structure as parameter, one more thing that I will tell you is that I told you that array can be either of two kind. One is like declaration can be like this. If declaration is like this, I told you that this is going to be stored in the memory, will be allocated in stack. Okay, the memory will be allocated in stack. But if I want to allocate the memory in heap, what I need to do, I have to take the array as a, for example, star b. Let me take a star b or a star c. I will take. Now this is a pointer, and now we have a memory allocation statement, like for example int star, the for which kind of pointer I'm allocating the memory to, followed by malloc. See, few people have asked me about the difference between malloc and calloc, that we will see later in the pointer section. Okay, see guys, whenever I'm teaching things, just follow it. Okay, all the things I will definitely cover in the upcoming webinar. Okay, so don't deviate from the flow. Okay, I'm placing it everything in the right place actually. So just go with the flow. Malloc, cloc, calloc, realloc, free, everything we will see in the pointer section. Similarly, coming to array, we have separate section for array. Okay, coming to function only, now we are saying we are concentrating on functions only. Pointer we will have a separate section, structure we will have a separate section, array we will have a separate section. Now we have seen only the basics of array, basics of pointers, and basics of structure. Now what does malloc have to do? I told you in the previous class itself. Here you have to specify the number of bytes should be allocated. Okay, number of bytes should be allocated. So for that, what I have to say, size of integer will give you either 2 or 5, 2 or 4 based on the compiler. And for example, if you want to allocate 5 blocks, then I can say multiplied by 5. So totally what will happen, if the size of integer is 2, 2 multiplied by 5, totally 10 block will be allocated. If the size of integer is 4, 4 multiplied by 5, totally 20 blocks will be allocated. Now what happens, the entire array is now allocated in heap, not in the stack memory. This is allocated in stack and this is allocated in heap. Now you can pass either A or C. If you pass C also, C means it is referring to the address, right? Address, because it's a pointer variable. C refers to address, star C will refer to the value. So either, both ways you can do. You can pass A also, you can pass B, C also. Both, but only difference is both are arrays, but this array is there in stack, this array is here there in the heap memory. That is the only difference. But all the other passing things, everything is the same. Okay, just I wanted to show you. That is why I have done this. Okay. So now clearly you have to understand is that array cannot be passed by value, but it can be passed by only address. Okay, fine. So now we will just move to call by passing a structure. Passing a structure. So I told you that array is not having pass by value power. That is a very big drawback, I told you. Yeah, it's a very big drawback. When you want to make a temporary change, you cannot do. Always the change in formal parameter will affect your actual parameter, which is a very big drawback. To overcome that drawback only, they have introduced you structure. See, what are all the drawbacks available in arrays was overcome inside structure. Okay, so that I will just teach you now. Okay, we will just have the same format. Okay, void no parameter we will give now. So now what I will do is just I will simply take a I'll just first of all define a structure. We will first of all define a structure. Struct rectangle, already we have seen this, right? Struct rectangle, and followed by inside this the member is going to be like length, and the other member is going to be, for example, breadth. Okay, followed by semicolon. So now you have defined a structure. Now in the main function, what I will do is I will just take I will just take a structure in stack. How to create it in a stack? Struct rectangle. Simplify, I'm declaring a normal variable called R. The memory will be allocated in stack, not in heap. How to allocate, how to set a value for this? 10, 5, for example. So now what will happen, this variable R will have two member called length and breadth, and now that length and breadth will be assigned with 10 and 5. Okay, fine. So now what is the next thing that I will be doing is that I will be just calling that func function and I will be passing R. Now you can ask me whether here pass by value or pass by address. Here pass by value. here pass, because the drawback of array is pass by value is not available. To overcome that, here in structure, what they have done is they have made it possible that a structure can be passed by value. Okay, so now what I will do is, here I have to receive it, or okay, I have to receive. So structure rectangle, either the same name or a different name, anything. Okay, I'll just receive it by D. Now what I will do is that I will just try to change the value of the length member and breadth member. So what I can do is d dot length is equal to 20, and d dot breadth is equal to 500, for example. So after calling this function, now I will just print to check whether it is affecting the actual parameter or not. So percentage d space percentage d, then followed by a comma, then I'll do r dot length, I will print, comma, r dot breadth also we will be printing, r dot breadth we will be printing, r dot breadth. So now we will just compile and check whether the formal parameter, change in formal parameter is affecting the actual parameter or not. Compilation is successful. 10 5, you can able to see 10 allocated, 5 is initialized, 10 5 initialized, same 10 5 is printed. So the change inside this function is not reflecting here in the actual parameter, which is telling very clearly that pass by value is occurring here. I can also show you here in the line by line process also. So structure rectangle r is equal to 10 comma 5. So if this line is executed, 14th line is executed, then r will be having two members called length and so main activation area is created. Inside main activation area, block for r, where inside the block r we have two member length breadth, both are assigned with 10 and 5 respectively. Now I'm calling a function. We will check whether this is called by value or called by address. I'll just enter. Okay, you can able to see that one more activation area is created on top of main activation area, and here you do not find any address. Which means that this is actually called by value. The entire array is passed here. The entire structure is passed here. Here there is no, see in the previous case, if you see, only address was there because that is I passed by address, but here the entire value have been copied here. One more block, see, one more block is created here, and in that block the entire values have been passed. For example, if I want to show you here, see, you have two blocks. Actually you have two blocks. Whenever you create a structure rectangle variable, whenever you declare a struct rectangle variable, you will get two blocks like this. Okay, in that you will have 1 minute. You will have two blocks like this, and this, for an example, the name of this is r, and it is having two members called length, and the one more member is called as breadth. Similarly, you will take two more blocks. You will have two more blocks, and suppose if I'm passing it to a different function. I'm telling you, if I'm passing it to a different function, then what will happen is, for example, the name which we give to it is d, and this will be having a new member called length, and also it will be having one more member called breadth. So whenever you pass a structure variable to another function, inside that function also a similar block like this is created. A dedicated block like this is created. Okay, so here a new block is created, like r, a new block is created, and only the values are copied to it. So this is a different block. This is here inside the main function you have r. This is a different block. So whatever change you do to this d will not affect it, because both are different block in the different activation area now. So I'll just change d dot length is equal to 20. You can able to see here that 20 value is changed here. But if you just go to main function and check r dot length, it is not changed, because both are different blocks actually. So no change will be happening, because this is completely a call by value. Okay, so again, if you print here, no change will occur because r will not be changed at any point. So this is called as pass by value. Okay, so array cannot be passed by value, but structure can be passed by value. This can also be passed by address. How to pass by address? Instead of passing r, pass ampersand r, automatically address of r will be passed. How address of R can be received? By using a pointer variable. Address can be always received by a pointer variable. So I will change this to a pointer variable. If this becomes a pointer variable, I told you already. For example, I'll just tell you here. I'm passing only the address. If I'm passing address and receiving it to use a pointer, a new block like this will not be created. A new block like this will not be created. For example, I'll just show you. Only a single block will be created. The name is D, and this D will be storing the address of this entire block. For example, 0x1234. And this address only will be here. 0x1234 will be there in the function. So now tell me, is D is having any member called length and breadth? No, R is only having length and breadth. So you cannot give D dot length because D is not having any length. So in order to bring the flow from here to here, we need to use star. That already I told you that instead of D dot length, you can use star D dot length. But we told you one thing, dot is having highest precedence. So first of all, what you need to do is that you need to enclose the star D with a bracket. I told you, parenthesis. But one more alternate syntax is given. That syntax is what called as arrow mark. When you use arrow mark, directly you can, from here to here, you can directly able to move. Okay, so what we can do here, you can change. That is why this error is shown here. Okay, so here what we can do, we can convert it into arrow mark. When arrow mark is changed, then the error is gone. Okay, we are changing into arrow mark. Now since this is a pass by address, definitely the change here will definitely affect it here. We will see that here also. We will first of all see it by using the normal execution process. Yes, if you see here, 2500 is changed here, it is reflected here. Now we will just go with the line by line process, and I'll just show you how this is happening in the inside the compiler. Okay, so here in a main activation area is created, and inside that you are having a block called R, where length and breadth the member is there. So once I execute this, automatically length becomes 10, breadth becomes 5. Now I'm passing the address of my R. You can able to see what is the address here. The address is like 0x62fe10. Address of R is 0x62fe10. So now I'm passing that address, so that address will be sent. Okay, my flow goes there. So one more activation area is created on top of the existing activation area. Now if you see, D is referring to the address. D is referring to the address. Inside that address only we are having length and breadth. Okay, don't think that length and breadth is shown here. Inside this address, this length and breadth is there. Okay, so but now address only we are having. So when this ninth line is executed, your dlar length is changed to 20. I'll just go to main function, and I'll show you in R also the length is converted the same time. So what is happening here? Pass by address. So whatever change that you're doing to the formal parameter is affecting the actual parameter. So if I change my d dot breadth, breadth also will be changed here at the simultaneous time. In the main function also, inside R, the breadth is changed to 500. This is what I wanted to show you. Okay, so one more thing that people might wonder, I'll just tell you one more thing. Suppose an array is inside a structure. An array is there inside a structure. Let me consider that it is like this. The array is like this. So what I will do here in the main function is, what is the first member, the second member, and third member is only length and breadth. What is the first member? Array. So instead of first member, what I will do is, I'll just create a 2, 4, 6, 8, and 10. So this first thing is array. So this will be assigned. This will be the entire part. This 2, everything will be assigned to my A. Okay, fine. So now tell me, whenever a structure is having an array inside it, whether it is possible to pass it by value, because we told that array cannot be passed by value, which is a very big drawback. And now array is inside a rectangle and inside a structure, whether now the structure can be able to be passed by value. Yes, it is possible. This is how the drawback was overcome in C, by introducing a new data type called structure. So now structure has overcome all the drawbacks that was there in the array. So now I will just pass it to pass R, and after passing R, now what I will just do is that I'll just by showing error. Okay, so here I have to change this into pointer. No, we have to remove the pointer, and now it's no arrow mark operator if it is a normal variable. If it's a pointer, then go with arrow mark. If it is not, then you can go with dot only. Okay, so no arrow mark is required now. Fine. Okay, now I'm just changing this into 20 and 500. Now what I will do is I will just change d dot a of 0. D dot a of 0, I will just change it to 500. I'll just change it to 500, and finally what I will do, I will just print r dot length, r dot breadth, and also I will just print r dot a of 0, r dot a of 0, which means that here inside the function I'm changing that 0th index element to 500. Instead of 2, I'm changing this 2 to 500, and now I'm printing it and checking whether it is changing or not. I'm just checking this whether it is changed or not. Okay, so we will check that. So by doing a normal execution process, we will check whether it is changing it or not. No, it still remains 2. It is not changed to 500. It means that clearly it is able to see that array is now sent as a call by value, not call by address. Array is sent as a call by value, not sent to as a call by address, because if it was call by address, then the change could have reflected here. But since the change is not reflecting here, I can clearly say that array is passed as a value, not as an array. That I will show you here in the line by line execution part also. Execution started, main activation area is created. Inside main activation area, I'm having R block, and inside R you are having A, which is having 4 index, and also we are having length and breadth column. So if 16th line is executed, automatically length and breadth are set to 5, and inside A if you see 4, 2, 4, 6, 8, 10 is also changed. Okay, so now if I call function, if I enter into function, automatically one more activation area is created on top of it. Now if you see, there is no address associated here. It means it is sent as a call by value. Now if you are able to see, array is also here. Array is not having any address here. Array is also entire element is passed. So here call by value. So whatever change you do here will not affect. So 20 is changed here, length. But if you go to main function and check whether the length is changed here, no, length is not changed here. Okay, I'll just go back there. I'll just change the breadth of it. If you see here, breadth is changed to 500, but let me go to main function and check whether breadth is changed. No, breadth is not changing. So whatever change that we are doing to the formal parameter is not affecting the actual parameter. Now we'll just expand a, and we will now just change this a of 0 to 500. A of 0 500, it is changed here, but when we go to main function and when we check here a of 0 is not changed, it remains still 2. So this is perfectly a call by value function. This is perfectly a call by value. Okay, so generally array cannot be passed by value, it can be only passed by address. That's a very big drawback. To overcome that drawback, we are entering into structure, and where a structure can be passed by value as well as it can be passed by address. Even though an array is placed inside, also call by value is possible. Even an array is placed inside a structure, call by value is possible. Okay, so this is it for the session. What you need to understand from here is that array cannot be passed by value, it can be only passed by address. Similarly, structure can be passed by both value as well as address. So it means that array hereafter is not suitable to present independently. If array is present inside a structure, then it will have greater power. Okay, I'm insisting you just write your array inside a structure and use a structure, then you can then it can have a great power. That I will show you. Okay, because so far we have seen monolithic programming, we have seen procedural or modular, still we have not seen object oriented programming. I'll just show you shortly how object oriented programming can be written. Okay, so thank you, and this is it for the session. There is no more session now in the evening session. We are finishing it with this session, so we will just resume back by tomorrow. Okay, so thank you guys, have a great day.